Hello everyone, it's Wilson here. Today let's look at this integral. This integral we have 2 minus absolute value x minus 1 and we are going to interpret this integral geometrically. That means we are not going to use the fundamental theorem of calculus and we are also not going to be finding the antiderivative. We are just going to figure out the region that's bounded by the limits and also the x-axis and also the function, right? And then what we're going to do is to find the area of that region, and then we can have the value of the integral. So first, we got to graph this function. So the function is y equals 2 minus absolute value x minus 1. And then if we rewrite it, then we can see that there is the negative absolute value x minus 1. And then what do we have here? Plus 2. Okay, so now what are we going to do? We are going to just use transformations to help us graph this function really quickly. So you know that for the basic y equals absolute value of x, right? That basic parent function for absolute value function. It's a V-shaped graph that looks like this, right? It's a V-shaped graph that looks like this. And the vertex is at the origin, okay? So now if we use transformations and then we can just move the vertex around, then we can actually come up with a graph of this V-shape without having to plot points. Okay, so the first thing that we are going to do is that we are going to just look at that minus sign right there. That's outside the absolute value function. That's in front of the absolute value function. What it's really saying is that we are multiplying the absolute value function by the negative 1. So that's a vertical reflection. And so you can see that vertical reflection, we are reflecting the graph about the x-axis, right? So now you are going to get this graph right here. Okay, so the vertex does not change, but then now you have this graph here. I'm going to erase all that eventually, but right now I'm just doing like a sketch so that I know how I am drawing the graph, right? Okay, so the next thing is that we are going to look at the minus 1 inside the absolute value function. What does that do? That's actually a horizontal translation. So that means you're going to move the graph left and right, right? And so the horizontal translation or horizontal shift. And what it does is that we are moving the blue graph, right? 1 unit to the right. So 1 unit to the right. Okay, so that means what? That means we are going to have our vertex right here. Okay, as you can see. And then the shape does not change, so we are still going to get the V-shaped curve right here. So that's just another step. Okay, last step right here, we are going to just worry about this last one right here. What does the plus 2 do? It's a vertical translation. And then the plus 2 tells you it's positive, right? So it's going to be 2 units up. Okay, so now if we move the yellow graph 2 units up, then we're going to get 1 and 2. So now as you can see, the vertex is right there. Okay, so we are actually ready to start graphing the function, and we can erase just all that stuff. Okay, so if we are graphing it, then you can see that we can plot some points right here. This is just the few points for the absolute value function, and I'm going to use a line tool to just connect the points so that we have an upside down V-shaped graph. Okay, it's an upside down V. And so we have, what is this graph here? It's y equals 2 minus absolute value x minus 1. Okay. And so now let's look at the limits. We have what? We have the limits from 0 to 3. So we are going to start from the y-axis, right? We are going to start from here. So what happened is that we are going to go from 0 to 1 and 2 and 3. So you know that we are going to stop here. Okay, so what's going on? We have a region that's bounded by the function, okay, the graph of the function, and then the x-axis, and also x equals 0 and then x equals 3. So now we have this region here. But this is an irregular shaped region. We do not really have a formula for this region, so we got to break it up into 2 regions so that we can find the area more easily. Okay, so one way that we can break it is that we can break it from 0 to 1 and then from 1 to 3, because now we're going to get a trapezoid and a triangle. So let's see that. So we're going to break it into two regions right here. Okay, so one region is going to be the trapezoid. And then we can just call this one A1, right? Let's just call that one A1. And then there is the other one, right? There is the other one. The other one, let me just use purple right here. So, okay, so that color is too hard to see. So now let me just use this purple color right here. Okay, so that works. And then the second region right here is a right triangle. So we call that A2. And then all we need to do right now is to find A1 and A2, and then we can have the answer for this integral. Okay, so let's just write down the regions right here. So A1, right? A1 is actually a trapezoid. So how do you find the area for a trapezoid? It's going to be 1/2, right? Times the base 1 plus the base 2. So there are two bases, right? And then times the height. Okay, so what is base 1? You can actually see that base 1 is just 1 unit right here, right? So that's base 1. This is base 1. Base 1 is 1. Okay, what about this base 2? Base 2 is going to be, let's take a look. This is actually 2 units, right? So you're going to get 2. And then also there is the height, right? So what is the height equal to? That's just 1 unit. So now we can just substitute the numbers in there. It's 1/2, base 1 is 1, base 2 is 2, and then the height is 1. So now what's our answer? It's 1 plus 2, which is 3, times 1, it's 3 over 2. Okay. Okay, so A1 has an area of 3 over 2. Now we also need to deal with the purple right triangle. Okay, so you can see that what happens is that this base right here, the base for the right triangle, is actually what? It's actually just 2 units, right? So we have the A2 is equal to 1/2 times base times height. And what about the height? The height is actually the base 2 of the trapezoid, right? Which is also 2 units. So I'm not going to label it because there are too many labels on here already. So we are going to get 1 over 2 times, what is the base? It's 2. The height is also 2. So now you are going to be getting, what is that? That's 1 times 2, which is just 2. Okay, so basically we have the answer, right? We have the two answers, we add them together, then we get the final answer. So the integral, okay, so now we can say that our integral is equal to what? Is equal to A1, which is 3 over 2, and then plus A2, which is just 2. Okay, and then we add them together, and you know that that's really just adding 2 and 1.5, right? 3 over 2 is actually 1.5, so you get 3.5. Or you can simply just get the common denominator and then write it as a fraction, which is 7 over 2. So that's it for this problem. And so you can see that we can, the shapes that we usually can run into is that we can run into a rectangle, a square, or a triangle, or a trapezoid. As you can see, this one is trapezoid, and we haven't seen anything like that for my past videos for this type of problem, right? This is the new one here. We have a trapezoid, but then that's for this problem. Okay. To help me make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. Let's work together to help students and children learn math more easily. Thank you for watching this video.